basic groups of fishes and starting to say something about them. We started off with the Agnatha. And Strocoderms. And we were looking at the Ostrocoderms. These are very, very primitive vertebrates. We know that they are vertebrates because they possess this outer shell of bone. Bone is a unique vertebrate characteristic. This particular mineral of hydroxyapatite is found in no other group except the vertebrates. And then I think we're ready to move on. Yeah. Then we can look at these are the same orders that appear in your book, I think. All right, so the agnathans, remember, are the jawless fishes. Ostrocoderms have no jaws, and we have a couple of living groups of fish that do not have jaws either. And we can put these into the order Myxiniformes and Petromyzontiformes. These would be the hagfish then, and the lampreys. Hagfishes are bottom dwellers. They live buried in the sand, and they're going to eat things like polychaetes, other invertebrates, dead, dying fish. All right, so a lot of the things that are on the bottom, that's what they're going to be eating. They're entirely marine, and we'll contrast that then with the lampreys. And they're characterized by having these sensory tentacles around the mouth. All right, you've already seen those in the lab in our jar number 4. Bluish green jar, remember that. They do have eyes, but they're pretty rudimentary, usually covered over with skin. Again, they're bottom dwellers. They're living in a world where there's not a lot of light, and they don't really need those eyes. They're unusual in that their blood is ice osmotic with seawater. So essentially then their blood has the same concentration of salts in it as does seawater. It differs from most other fishes that have a lower concentration of salts in them. Right? And they do not have a free-living larval stage. Again, we're going to contrast that with the lampreys. So the lampreys have different lifestyle. Most of these can be considered to be parasitic. Instead of bottom dwellers living on, feeding on living polychaetes or dead and dying fish, most of the lampreys are parasitic. In other words, they're going to attach themselves to the side of the fish, rasp a hole in the side, and then suck out the juices. Hagfish are entirely marine, but the lampreys are all going to live in fresh water for at least part of their life cycle. Many of the lampreys are anadromous. What's that mean? You have that term in your course pack. Nope. The other way. Saltwater to freshwater.
They spawn in the freshwater.
Yes. Right. So there, many of them do live in the ocean, and then they will come up into fresh water in order to lay their eggs. Right? So anadromous. They ascend. Double A's. So A for ascend. Anadromous fish ascend the streams in order to spawn. The lampreys have functional eyes, as opposed to those rudimentary eyes of the hagfish. In addition, they have a median eye called the pineal eye. So the concept of a third eye is foreign to many students, but it is something that is found in fishes. It can be found in even various reptiles today have a median eye. All right, so this is a third eye. It's not on the sides. Instead, it is along the dorsal midline. It is an outgrowth of the brain. And the function of it, more than likely, is simply to monitor light levels in photoperiod. In other words, it does not see, it does not form an image, but it does monitor light levels in the length of the day. And more than likely, this allows the animal then to synchronize its daily and annual activity to patterns of daylight, the length of daylight. Ostracoderms probably had a similar type of a structure, and we think that simply because there's an opening on the top of Ostracoderms, so an opening in their shell about where you would expect that median eye to be. So we did have median eyes in the ancient animals, ancient vertebrates. We still have median eyes in some of the living. What else? Oh. Unlike the hagfish, we have a free-living larval form. So, for example, for for many lampreys, 3 to 7 years, they're going to have a larval form that's going to be out there living around, and then it will metamorphose into the adult. And you saw an example of that in labs with the Ammocetes larva. That was the larva of the sea lamprey. All right, so that's a specific example. All of the lampreys, though, are going to have this free-living larval stage. All right. So I'm not going into a lot of details on these. I just want to do some basics. We're talking about jawless fishes. We have a very large extinct group, the Ostracoderms. It's what the Cladis would say is paraphyletic. There's a lot of different lineages in there. But the important thing about that group is that they are the most primitive of the vertebrates. You can read Conodonts, so you can read about those if you want. And they had that outer shell of bone on them. Today we still have agnathans, jawless fishes, the hagfish and the lampreys. Those two groups really are very different from each other. They're not closely related even, but they do share that characteristic of not having any jaws. All right? So the agnathans is a large group of animals. The opposite to the agnathans is the gnathostomes. Remember, gnath, the G-N-A-T-H, means jaw. Stome is the Greek for opening, the stomata of a plant, for example. So these are animals that do have jaws. So among the vertebrates, we have the agnathans and the gnathostomes, and that then applies to all of the vertebrates that ever have and ever will be. So these groups are all characterized by having jaws. There are two major extinct groups. A lot of times they're looked at as classes, but just remember the terms. So we can call one group the placoderms and the other one the acanthodians. So extinct groups of gnathostomes. Placoderms resemble the ostracoderms in many ways, especially in the idea that they're covered by bony plates. A big difference, though, is they do have jaws. There's no teeth, but they have jaws. In addition, if you remember, those ostracoderms did not have any paired fins. Some of them had lateral extensions of that bony armor, but they did not have true fins that could be moved. in the placoderms, we do see the development of pectoral fins, and many of them also had pelvic. So if you look at handout, well, it's the second number 2. The second number 2. There's 2 groups of numbering in that pack. Yep, to the left. Anyway, those are placoderms. And if you just flip your pack over and look at the ostracoderms that you looked at yesterday, you can see that there is a similarity between ostracoderms and placoderms. And that similarity is that they are covered by that bony armor. Both groups were. But then when you look at the placoderms, you can see those paired pectoral fins very readily, and you can even see a paired pelvic fin on the one that's in the middle. And again, these were jawed animals, but they're all extinct. Acanthodians, they are taking those bony plates and they're going to reduce them in size to some bony scales instead. They are different because they are the first group of vertebrates to develop teeth, so true teeth. Their most distinctive characteristic, though, is they had a lot of spines on the body, and they also had pectoral and pelvic fins. So if you turn the handout over to number 3, it'll give you some outlines of acanthodians. You can see how they have those spines. So I just want to introduce you to these 2 groups, the placoderms, the acanthodians, make some comparisons with the ostracoderms. All right, so both of these groups, the placoderms and the acanthodians, had paired fins. What's the advantage of having paired fins? What good are they? Turn left and right. You mean without paired fins you can only turn left? Okay. But it's got the right idea, and the idea is it is a certain amount of maneuverability. What paired fins can do to you is they can increase your stability in the water, so you don't keep going, you don't roll in aerodynamic terms as much. But they also give you a fair amount of maneuverability. You can turn left, you can turn right using those fins. So paired fins in general are not being used for locomotion. In other words, they're not propelling you through the water. Right? There are some exceptions, but in general, that's not what paired fins are used for, your pectorals and your pelvics. Your pectorals and pelvics are more for stability and maneuverability. All right. So that was a new development. The other new development, of course, is the jaws, the gnath in these guys. And so this is looked at as a huge development in the evolution of the vertebrates. It gave them a much greater advantage over the jawless individuals. Okay? Your jawless individuals have difficulty processing foods. Many of them, such as the ostracoderms, probably were filter feeders. You have the lamprey that is just sucking out juices. Even the hagfish cannot process large pieces of material. Once you develop jaws and once you develop teeth, you now have the ability to manipulate food and objects in your environment. You now have the ability to grasp prey, prevent it from escaping. You now have the ability to reduce the particle size. So if you have a large item of food, you can make that into a small item of food and process that internally. Having jaws then opens up a lot of new niches that jawless vertebrates do not have open to them. So we want to look at a few things about jaws. Well, where did jaws come from? In other words, you have 2 options in evolutionary history. is something just created de novo. In other words, it's a